We're going to start off with list. So here's our vessel floating in seawater. There's our metacenter, our center of gravity below our metacenter. That means we have positive GM, positive stability. There's our center of buoyancy, also on the center line. This vessel is in the upright condition. It's at rest. All right, and it wants to remain at rest until acted on by an outside force. So we're going to go ahead and take M out of the picture here just to keep the animation simple. Okay, now what has happened there is that we shifted some cargo to the starboard side. And essentially what's happened here is that the weights that are loaded on this vessel are no longer equally distributed around the center line. There's more weight on the starboard side, we're looking at the vessel from the stern by the way, than on the port. So we actually have more moments on the starboard side. As a result of that, center of gravity has shifted. Now, you'll see that G and B, I stopped this motion here, but this vessel actually wants to incline to starboard. All right, and it wants to do that not because of an external force, but because of an internal force. Internal, G is off the center line. And B is, you can see that G and B are now separated by a distance. That's a couple. And there is an arm here between those two. We refer to the distance between G and B as GZ. This is actually, instead of a righting arm though, this is an upsetting or capsizing arm. And the vessel is going to continue to incline until B moves out underneath G. So let's see that. So the vessel inclines. Okay, now the vessel has come back to rest. B is back underneath G. The vessel is no longer upright, but it is back at equilibrium. Okay, we're just going to just look at what happens now. I just removed B just for a minute. And this is the new center of gravity. This is the angle of list. Well, the reason why we're concerned about angle of list is that now when the vessel rolls, it's going to roll around this new angle of list. Let's say this vessel is inclined 10 degrees to starboard. Well, if it rolls now 10 degrees to, additional to either side, the vessel is going to roll to, let's say, 20 degrees starboard. Okay? And then it'll roll back, maybe almost upright, back to starboard. Okay? So the vessel is now rolling around this new center of gravity. This is why list is dangerous, because as the vessel rolls, you're going to be very close to deck edge on one side. So how are we going to get rid of this angle of list? Well, there's a couple ways we can do it. If we just remove this weight, let's say we discharged it, G would move back to the center, and the vessel would come back to the upright. Another thing we could do is we could create an equal moment on the opposite side of the ship. So let's say that this was a 20-ton weight, and we had moved it 20 feet off the center line. Well, 20 times 20 is 400 foot-tons. It's a moment of 400 foot-tons. So all I have to do is create a moment of 400 foot-tons on the port side, and the vessel will come back to the upright. I could do that by putting 20 tons at 20 feet, or I could do it by putting 40 tons at 10 feet. Okay, that would be the same moment, and the vessel would upright. For this animation, though, we're simply going to remove this weight. So as soon as I remove that weight, you can see G is moving back to the center line. And at that moment that G moves back to the center line, you can see that G and B are separated again, so we have that arm being created, GZ. In this case, though, it's a positive righting arm. It's and the vessel is going to come back up to the upright position. Okay, great. Now the vessel will roll around the center of gravity again, but this case it'll roll equally to either side. This is much safer than having an angle of list. Okay, now what we're going to do is we're going to look at Loll. You can see right off the bat that Loll is actually, with list we had G below M, but with Loll, G is above M. This is negative GM. This is dangerous, okay? We're going to look at that now. So there's our force of gravity working down, our force of buoyancy working up. I just removed M from the picture again just to simplify the animation. So this vessel actually is not going to want to stay in the upright position. It does not have any initial stability. If it's acted on by any external force, it's going to immediately incline on its own to one side or the other. So let's say we applied a force on the port side. It could be a wave, could be a tugboat pushing up against the vessel. Okay? As soon as we do that, something interesting is going to happen. Okay, so the vessel is inclining, but because G is so high, G is moved. You can see here in this example, the center of gravity is actually not moving. It's staying in this position right here. Okay, this distance from the keel, and it's still on the center line. But you can see as the vessel rolls that B is not moving out with G at the same rate. So we have an arm here again, a GZ, but in this case that GZ is a capsizing or upsetting arm. And this vessel is going to continue to incline. Even if there's no force, a force can just start it in motion. You could remove that force. The vessel will continue to incline until B moves back underneath G. So this is Loll. This vessel is now inclined to starboard, maybe 10 degrees. Now, if you just walked up to this vessel, you might say, "Whoa, this vessel must have some off-center weight." But that's not the case. Off-center weight creates list. The vessel does not have an off-center weight. You can see that G is on the center line, but G is above M. So we have this situation of it. Let's just talk about one other big distinction between Loll and list. When you have list, the vessel is inclined to one side or the other, and it rolls around that new center of gravity. But with Loll, the vessel can be inclined to port or starboard, okay? And the vessel can actually flop from one side to the other. And we're actually going to see the physics of that here in just a moment. So let's say we acted on the vessel again, this time from the starboard side. Could be a wave, could be a tugboat again. So the vessel now starts, so that force is now going to start to push the vessel back to port. Well, the first thing you're going to see here is that the vessel is actually, if you look at this arm here, this is a capsizing arm again. We applied a force here. Maybe it was a big wave. Well, the vessel itself is actually trying to incline itself back to starboard. But if that force that was imparted was big enough, greater than this arm that's being created here, the vessel is going to continue to roll to port until it gets back up to the center line here. Now the vessel is upright again, but the vessel is in motion, so it has momentum. So it's not going to stop. It's going to continue to roll past this. And now we'll see that as it does it, just as it does that, there is that GZ again, which is capsizing, upsetting. And the vessel is going to continue to incline to the other side until B gets back below G again. Now, this is the difference between Loll and list. The vessel was inclined to 10 degrees on the starboard side. Now it's inclined to 10 degrees on the port side. And this vessel can flop back and forth to either side. Whereas when we had list, the vessel was inclined to one side or the other. Okay, so now how might we get rid of this? Well, you have to be careful here. Your inclination might be to say, oh, well, you know, this vessel is probably inclined because it has an off-center weight. Well, we can see from where the position of G is that that's not the case. This vessel has negative stability. But if you weren't really paying attention, you might be inclined to say, hey, maybe we should load some weights on the starboard side to overcome this. That would actually be the worst thing that we could do in this situation. Because if we do that, okay, as soon as we put that weight off center on the starboard side, the vessel is going to start to incline. Okay? But the vessel also had a Loll to that side. So look what's going to happen here. Loll and list are going to combine now, and the vessel is really going to go a long way. Look, we're right at deck edge immersion here. Okay? This is not what you want to do if you have Loll. All right? This is an unsafe way of trying to correct for Loll. Don't do this, okay? Angle of Loll occurs when G is on the center line but above M. Okay, and if you shift waves transversely, you're also going to create an angle of list. Those two are going to work together, and the vessel is going to incline even further and perhaps even capsize. So, all right, this is incorrect and dangerous. So how would you actually correct this? Well, all right, here's the vessel lolling on the other side. It flopped back over. The reason why we have Loll is because G is above M, negative GM, negative stability. Well, if we could somehow get G down below M, the vessel would right itself. So we can do this by ballasting. Now, technically, the best thing to do would be to ballast on the low side, but I'm just going to go ahead and ballast evenly across both tanks here. And you'll see that that brings G below M. And as soon as that happens, you saw that G, when it was high, was in line with B. But if I can bring that down, you can see that B now, oh, look at that. We have another a GZ here, an arm. And in this case, it's a positive arm. The vessel is going to right itself. All right. So here's just a little summary slide of sort of list and Loll. All right. And that's the end of this video. Thank you.